Okay, so in this we do problem, we have 50 milliliters of a zero point 0.5 molar hydrochloric acid solution. We have 50 milliliters of a zero point 0.5 molar sodium hydroxide solution. We have an initial temperature of both solutions at 19.8 degrees Celsius and our final temperature 26.3 degrees Celsius. We need to do two things in this problem. One, we're going to calculate the heat gained by the mixture. And two, we're going to figure out what the heat of the reaction is per mole of sodium hydroxide. So for the first part, calculating the heat gained by the mixture, first of all, heat gained we know is endo. Now the reaction itself is exothermic, but the mixture is really the solution. So using Q equals MC delta T, we're really trying to figure out the heat gained by the mixture. So Q of mixture. Now this gets a little tricky because the mixture is going to need a mass and a specific heat. Well, assuming that this is aqueous solution, so we know it's in water, we're going to assume that we're using the specific heat for water, which we know is 4.18 joules per gram degree Celsius. We've seen it before and we'll always be given that. The mass, however, is the mass of the water as well, or mass of the solution. And so we've got 50 milliliters added to another 50 milliliters. So we have a total of 100 milliliters of solution. Now we're going to assume that this is going to be the same as the density of water. There we go. So the density of water is 1.0 grams per milliliter. So knowing that the density of water is 1 gram per milliliter and we have 100 milliliters, we're actually going to put a big assumption here and say that the mass of our mixture is pretty much 100 grams. So those are some big things we need to kind of get out of the way in the beginning. Once we have that, we can just go ahead and plug into Q for the mixture, and we can use the mass, which we said was 100 grams, the specific heat for water, which is 4.18 joules per gram degree Celsius. And then our change in temperature is going to be our 26.3 degrees Celsius minus our 19.8 degrees Celsius. Now, when you calculate that out, I think you get a temperature change of about 6.5 degrees Celsius. That's important because that only has two significant figures. So when we actually calculate this out, we get a heat gained by the mixture of 2,717 joules for two significant digits. That's going to give us 2,700 joules, or we could report that in kilojoules as 2.7 kilojoules. I like that better. That looks a little bit better. Okay, so that's the heat that was gained by the mixture. Again, we know it's positive because it's endothermic. Now the second part, the heat of a reaction per mole of sodium hydroxide. So remember, the sodium hydroxide and the hydrochloric acid are actually reacting. So the heat of reaction in this case is exo. It is that reaction is giving heat to the surroundings, which is the solution. So that's going to be a negative Q that we're solving for here. But in this one, we want heat of reaction per mole. So technically for the second question, we are looking for Q over moles of NaOH. So the first thing we need to figure out is how many moles of sodium hydroxide do we have? Now we have a molarity here and we have 50 milliliters. So we know that we have 50 milliliters of solution. And we know molarity is moles per liter. So let's go ahead and convert that to liters. There are 1,000 milliliters in a liter. And then using molarity as a conversion factor, I have 0.500 moles of NaOH for every 1 liter. That gives me a total of 0.025 moles of NaOH. Okay, I'm going to move this up a little bit. So going back to my Q, the heat that was gained by the solution, or by the water technically, was 2.7 kilojoules. So if I want heat of reaction per mole of sodium hydroxide, that's going to be negative 2.7 kilojoules of heat per 0.025 moles. And so we end up getting negative 110 kilojoules per mole for the heat of reaction for sodium hydroxide.